Hi everyone, welcome to our first instructional video. This is the start of the Force and Motion unit. This is going to be our new unit. We're on to real science, and today is just going to be the intro day. The rest of the week we'll be doing more hands-on stuff. So, force and motion is the science of how and why objects move. You will be driving cars in a couple years. You're moving every day, so this topic is highly relevant to you. And it's important to be able to analyze that information because you want to be able to tell, how fast objects are going in case they interact with each other and potentially crash. You need to be able to graph distance, displacement, acceleration, velocity, all kinds of cool things. And they will also be on the MCAS next year, so you're going to learn about it now. You are going to take notes as part of this process. Remember that if there is a star in the corner, then you take the notes. So you're going to write about 4 vocab words worth of notes today. So make sure your journals are out and you're ready to go. Feel free to pause this video at any point should you need time to finish writing. Alright, so position. Position is quite simply the location of an object. So currently my position is on my bed in my room, giving you this video in my science gear. I hope you like the glasses and the lab coat. I don't know if you can tell, but it does actually say Miss Gately on it. Position is represented as an X, which just means the place, and that's actually where you get the phrase X marks the spot for a treasure map. So this X would be the position of the treasure. When an object changes position, it's known as motion. It means that it's moving. But you do need to have these notes down. Note that the title has the star, so that means these 3 bullet points need to be written in your journal. Feel free to pause the video and then move on when you're ready. So motion is the act of changing position, as we just said. It can happen in any direction, so up, down, left, right, sideways, diagonal, and it does not have to be seen to occur. So in this image here, clearly the man started here, he ended here, and we can see all the in-between steps as he did a backflip. But even if we blocked all the middle and we saw he started here and ended here, it's clear he must have moved because his position has changed. So you make sure you write down these 3 bullet points for your motion vocab notes. Displacement is a little bit different. It might be a word you have not heard of before. It's the change of position, but it takes into account how far you went and what direction you went. So if you look at this image down here, here's the start, and this person, they traveled the green line all the way around. They went on a nice walk, but the displacement is the quickest way to get from where you started to where you ended. So it's the direct line that connects the 2 points. So even though this man traveled all this distance, which is our next vocab word, his displacement from start to finish was actually only this black line. And it looks like it was in the positive direction. So make sure you write those notes down. And then lastly, distance is the magnitude or amount of change in position. And in this case, the direction does not matter. So back to the original image, the distance is all the steps taken in between. So the distance in this case would be a lot greater than the displacement. And then if you look over here, if you think of yourselves going from home to school and then back again, the red line might represent one student who took this route, green line is another route. So the distance for these 2 students would be different, right? The green looks like it's longer, it'd be a longer distance. Blue would be the shortest distance, red would be the intermediate distance, but they have the same displacement, which is this blue arrow, meaning where they started and where they ended is the same distance, so the same length apart, which means that even though their distances are different, their displacement or their overall change is the same. So make sure you write these down. We're going to do a couple examples, so you can pause the video as necessary to help you visualize this when you're ready. But we are going to need a volunteer, so if someone could raise their hand, that would be great. Alright, so for example 1, if you could please show a position of -2. Just stand next to it and put your hand on it. For example 2, if you start at position 0, show a distance of 5. You can use your hands for the start and end. For example 3, take a different path, so start at 0 again, but take a different path to show still a distance of 5. Think about direction in this case. Good, and lastly, you start at 0, show a distance of 5 and a displacement of 1. So thinking about distance is all the steps, and a displacement is just from start to end, how far apart are you? That one's a little bit trickier. See if you can do it. Alright, so all this was hopefully helpful, but I do want to give you another opportunity to have someone else show you and use a couple images. So we are going to watch a short YouTube video. I will full screen this for you guys. Alright, here we go.
In this video, we're going to talk about the difference between distance and displacement. If this car moved from point A to point B, we could say it traveled a total distance of 100 meters. Distance is a measurement of the length between 2 points. Now let's go back to this example and add another road sign here. Let's bring this one in so we have a direction. Now if the car again traveled from point A to point B, we could say that it traveled a distance of 100 meters, but we can add in another part of this measurement. We could say it traveled 100 meters to the east. And this is actually a displacement rather than a distance. The difference is that we're including a direction this time around. Now the definition for displacement is the overall change in position. So we're looking at a starting position comparing it to a finishing position. And then the other big difference here is that displacement is going to include a direction. Now displacement includes a direction, and so we call this measurement a vector. And so measurements that include directions are called vectors. Distance doesn't include a direction, and so it's called a scalar. Let's add another road sign here in our example. So if we add this extra midpoint here road sign, we'll bring our car back to the point A, and if the car travels from point A to point B, and then just backs up here to the center here, let's see how far it traveled. Now it's traveled a distance there from point A to point B of 100 meters. And then it traveled an additional 50 meters for a total distance of 150 meters. Now if we look at its displacement, however, we're comparing its starting position, which was right here, to its finishing position, which is right here. And so its total displacement would be 50 meters to the east. In other words, it's 50 meters east of where it started, which was right here. Let's look at another example here. If you've ever run track and field, you may have had the chance to run the 400-meter race. The 400-meter race is one lap around the track, and for a total distance of 400 meters. Now, what would the displacement be? Well, if we compare your starting position right here to your ending position right here, we would say that your total displacement was 0 meters. And it's almost like if you were running the race and all the fans just shut their eyes as soon as the gun went off and then opened them again when it was all over, and it looks like you're in the exact same location. Your displacement is 0.
Alright. So hopefully you find that a little bit helpful. It's just another way to think about it. It's interesting that if you run on a track, if you start and end in the same place, your displacement is actually 0, because from point A to point B, the direct line is non-existent. You haven't moved. But if you are thinking of your distance, that's all the intermediate steps, that would be the 400 meters. So today, in order to practice all of these concepts, you're going to do a practice worksheet. And it's really important that you read all of the words. I know it looks like a lot, but it's very simply written. It's just for you guys, perfect for your level. And so they give you lots of examples. So this is the beginning of the worksheet. It says reading positions, and you'll practice, giving answers. And if you'll notice, they give you a full example, 3 questions, and 3 answers. So if you read through this and look at their examples, you should have no problem answering the questions that follow. Now, if you have questions for me, you're of course welcome to ask, but if it is explicitly given in the directions, I probably will not answer it. I will just tell you to reread the directions. That's a really important skill. Super, super important to make sure you read everything, because someday when you are, getting a car loan or buying a house, you want to make sure you're reading all of the words on the page, because you might be signing up for something that you aren't realizing because you did not read. So we're going to practice that all year, making sure you read the directions and follow them accordingly. All right, thanks guys. Good job.